overshoot amplitude. Okay. So coming back to this diagram again, right? Coming back to this diagram again, you have your first overshoot, and then you have your second overshoot. Most important thing is you have to observe your pi and your what? And your 3 pi. Okay. So from here, we know that this will be equal to E minus zeta 3 pi over square root of 1 minus zeta squared. Divide, and that's the x-axis over here. Okay. And x E minus zeta pi square root of 1 minus zeta squared. So this will be equal to E minus zeta 2 pi square root divided by square root 1 minus zeta squared. So now you put in your numbers. Minus 0.235 multiplied by 2 multiplied by pi divided by square root of 1 minus by 0.235 squared. Okay. So from here, your subsidence ratio will be equal to minus 0.235 times by 2 times by 3 pi divided by square root bracket 1 minus by 0.235 squared, close bracket, and then exponential function 0.219. Okay, I will do it again. Minus 0.23 minus 0.235 times by 2 times by shift pi divided by square root bracket minus 0.235 squared, close bracket, exponential function of the answer. It's correct. Okay, so that is our subsidence ratio. And finally, we are going to calculate our settling time. TS, okay, to 2% XSS. Okay, 2%. Okay. So for this case, we just need to look at the decay to 2%. Okay, so we know that 2%, so it's 0.02 XSS is equal to E minus zeta omega n TS. Okay, or we have XXS again. Okay, so TS is the settling time. Okay, I forget, is that omega n or omega? On zeta, I have to go back to my function again. Is zeta omega n. Okay, so from here, we can get rid of XXX. Okay, so you do natural log on both sides. So this is equal to minus zeta omega n TS. Okay, so natural log of 0.02 minus 3.912. Now, when you see the minus down here, also don't panic, okay? Because you start to panic, you say, Eugene say there's no negative time, but there's a negative, you start to panic. Don't panic, because when you natural log 0.02 is also a what? A negative sign, okay? So this is equal to minus zeta omega n TS. So finally, we calculate our TS is equal to 3.912. Divided by zeta omega n. So this is equal to 3.912 divided by zeta is equal to 0.235. And then after that, we have our omega n, sorry. Omega n, 11.738. 11.738. So this will be equal to 3.912 divided by 0.235 divided by 11.738 is equal to 1.418 seconds. Yeah, so 3.912, 1.418 seconds. Yes. There is a natural law on the right hand side because natural law of exponential function, you cancel both of them, right? Wait, sorry, I skipped step. Make sense? Yes. Say it again. It's the decay portion. Oh, not this one, sorry. It's this one. Anyone, any question? With this, we conclude our mechanical vibration. Okay, now listen. When you do your mechanical vibration, I think it's 3VO3 or something like this, okay? I will ensure that these notes are still what? Available. Are we clear? Okay, you can still access this, okay? You will forget, I'll tell you this for sure. You'll forget this in week 5 of this term. I don't blame you at all, okay? We are cramping so much stuff into your mind and you are taking 8 courses in a term. Some of you are like, you're doing too much, okay? I'll still leave this available for you. Are we clear? I will not get rid of this until you graduate from McMaster. Are we clear? Okay, so you will always have access to the notes and you will also have access to the videos where you will make me sound like Mickey Mouse. Right. Go for a 5 minutes break. We come back. We start a new topic that's going to be worse than what we are doing now.